Hello folks, welcome back to my YouTube channel. We are in the Python for data science module, and our today's topic of discussion would be indexing on NumPy arrays. Then we will have a look at what is Boolean array, and proceeding further we will have a look at whether we can iterate on a NumPy array, and then we will have a close look at how to manipulate and reshape NumPy arrays. So let's jump in. As you know, first we need to import NumPy library. Just executing this first line. And this is an array's name that you already know from our previous two videos. Now I would just create a simple NumPy array and do what? I would like to only print first four elements. Then what I would apply? I would do slicing using indexing, the way I did for lists and for that matter strings in our basic course. So the same way you use the index will start here as well, from number 0 and 0, 1, 2 and 3. So number 4 will get excluded, that is the index 4 will get excluded. All right, so the result you get is 1, 2, 3, 4. Then if you want to use negative indexing, you can use negative indexing as well, and you can start at -5. Here it is -5 minus which number is at -5? Let's have a look. -1, -2, -3, -4 and -5. So it will start at 3, and what number is at -7? It is 1, right? So -7 will get ignored and it is going in the direction of -1. So it's negative indexing, so only 3 and 2 will be displayed. Similarly, if it traverses in opposite direction, we will have to mention 1 over here. So -5 to 1 and then increment by 1. So you can whatever size you want, you can put it over here, as this is parameter for step size. So it's very much the same indexing that we used in strings and list. All right. Now let's move on to the concept of Boolean array. Now suppose if I want to write array, I'm using a range function here. So as it was a range function in Python, here in NumPy we have a range function which allows you to insert a step size of decimal numbers. Suppose if you want to create an array of decimal numbers and you want to give a step size of, say, I'll just show it to you over here. Suppose you are creating one array in range, say np.arange here. Then you want to insert a decimal number as a step size. So you are starting from 1 going to 5 and you want to insert a step size of 0.5. So if you do it via simple function range that we use in our for loops, this will not proceed ahead. I mean, that will give you an error stating that it will ask to give an integer value. However, with arange you can give a float value step size as well. So here we are using arange, not really utilizing the float value, but I'm just telling the difference. All right, because you might see that arange is a new thing. Now ARR is equal to, I'm creating an array and I'm creating an array of range from 1 to 15. Now if I print ARR, then what would I get is the array from 0 to 14, right? And look at this. When you execute ARR less than 6, you got some different array, and that array has got values as true and false. And this kind of array that has values only of trues and false is nothing but called as a Boolean array. Look at the way the comparison is done. Comparison is done on element to element basis. Okay, so after this what we will do is whatever I think this is something that we saw in our earlier videos when we saw comparison operator. Now using this Boolean array, what we will do, we will run that Boolean array on our original array, and this is how you run it. This is the syntax. So ARR, in the bracket you give the condition, and the resultant array that you will get will be of only true values. So let's just have a look at it. Look at this, true values. Our original array had 0 to 14 numbers, or you can say 0 to 14 elements. All right, and what is the output that we got is from 0 to 5, because in this we had mentioned ARR less than 6. So I said the true values will be written. You can see only for first 5 positions there are true values, that is 0, 1, 2, 3, 4 and 5, and from next I mean from 6 onwards the condition doesn't match and it has false. That's why I said that only true values will be written. This concept is called as fancy indexing, or Boolean indexing. It's some books, even they will call it as maxing. So no need to confuse. These are all the same terms. Now just tweaking around on the conditions. All right. So if I say I want only even numbers from the above array. So I would just write the condition for the even numbers and I will run it through on the original array. Wherever there are true values, those will be written. That's the reason I got the array of even numbers. Similarly, I can have a combination of conditions wherein we are now checking the numbers that are divisible, completely divisible by 2 and completely divisible by 3. That's the reason we have used modulus 2 and modulus 3 and we are expecting their modulus to be 0, that is the remainder to be 0. And what we are trying to return is an or condition. If you have a look at it carefully, I'm using bitwise or and not the and or operations that we normally use. I'm using a bitwise or here. The reason is whatever the combination I'm trying is whatever the combination of conditions I'm verifying upon is nothing but a Boolean array. That's why I'm using bitwise operator. Okay, so you would get a result of all the numbers which are divisible, completely divisible by 2 or are divisible by 3. Okay, so this is nothing but just for your understanding, so that you are aware that these are the true values that were written, and using or condition, if any one of them is true, those were written. After that, I'll just run a ARR again so that you don't have to go back and see. And np.where, now I'm using a where function. What it will do is returns indices in tuple. Okay, so if I do arr less than 5, it is not going to actually return the values, it will be returning the indices. That's another thing, that here the values and the indices are the same, however it is returning the indices. Okay, so if I run this, you would see arr less than 5. So these are the values till here. Just hold on, less than 5. So till here, these are the values which are less than 5, right? So what it has done is it has returned the index of those values. Okay, not the actual values. Now if I want to further enhance, or you can say further, I want to utilize more functionality from the where function. What I'm trying to do is, wherever at whichever index you get arr less than 5, just specify the original value, keep it as it is, and which are not, you please increment it by 1. That's the result I'm expecting. So the result I'm expecting is 0, 1, 2, 3, 4. All right, and from 5 onwards I will add 5 to each and every element, that is 10, 6 plus 5 11, 7 plus 5 12, and so on. So let's see if I'm getting the result. So you might treat this like if else condition that we studied in control statement. So the if the index value is less than 5, keep the actual element as the same element that it was original, else change it and add 5 to it. So let's see if we achieve the expected result. Yes, and that's it, we have achieved the expected result. Now let's move on to the next section. Can we perform an iteration on a NumPy array? Yes, you can very well do that. It's just for showing it to you that this operation is possible as well. All right, so we can iterate on a NumPy array. And now let's jump into our next section, that is array manipulation and reshaping. How do we reshape or how do we manipulate arrays? So the same function I have used np.arrange. This time I'm reshaping, and with np.arrange I arrange 12, I will get 0 to 11 elements, right? I mean 0 to 11 numbers, and that will be in one dimensional array. However, I want to reshape into 3 by 4 matrix, and that's why I have used this reshape function, and with that reshape function I will be able to reshape the existing array. This is the repeated statement, I don't need it anyway, so I'm just deleting this one, and I'll show it to you what is the value in arr1. You can easily see the I have reshaped using the arrange function. I took the range from 0 to 11, and using reshape I created a 3 by 4 matrix. Now similarly I can create, and now I'm using random.random function to create a 3 by 3 matrix. Now here I can create 3 by 3 matrix of numbers between floating numbers, and that is float numbers between 0 to 1. All right, numbers between 0 to 1 of float data type. Now what I'm doing is I'm taking the floor function, okay, and I'm creating a 2 by 3 matrix and multiplying it by 100. So if you look at this output clearly, so when you use floor function, we all know that whatever is after decimal point will be removed. Okay. And what has happened? We have multiplied it by 100. That's the reason we are getting this output as 20 dot something or something. Else, the random, we all know the random function generates what? Generates the decimals or the float values that are between 0 to 1. But however, if we multiplied it by 100, that's why we got 20 dot something, 88 dot something. Okay. And the with the floor function, the rest part was ignored. Okay. Now moving on to the next one. I think transpose is something that we'll see later. So I'll delete this from here. Now let's have a look at flatten and ravel. Now we saw how to convert from 1D to the 2D or 3D, whatever dimensions we wanted using the reshape function. Now if we want to convert a 2D array into a single dimensional array, then how do we do it? We have two functions. One is flatten and another is ravel. Alright. So if you look at this, flatten function and ravel, both are giving exactly the same results. What they are doing, it's a 2D array that we have. In the first row we have 1 2 3, and in the second row we have 4 5 6. However, it has flattened that this 2D array to a one dimensional array. So for flattening we have these two functions, ravel and flatten. Now to move on further, we have array 1 and array 2, right? So let's see how we can perform row wise or column wise aggregations, because what we are looking at is manipulation and reshaping of arrays. So let's see how we can manipulate the values using the row wise and the column wise addition for the given arrays. So here I have defined one array. Okay. In this array you could see there are 9 elements altogether, and it's a 3 by 3 matrix. Okay, that is 3 rows and 3 columns. When I do np dot sum array 1 and I specify axis is equal to 0, so what is this axis is equal to 0? It will aggregate on data across columns and sum the value of each column. In the sense, across rows, it will aggregate the values across rows, that is this rows, these are the rows, and somewhat sum across columns, right? Sum the values of columns. So 1 plus 4 plus 7, 2 plus 5 plus 8, and 3 plus 6 plus 9. So that would give me what? That will give me, for the first column it will give me 12, for second it will give me 15, and then 18. So it sums the values of each column when you specify axis is equal to 0. And similarly, when you specify axis is equal to 1, it will sum the values of each row. 1 plus 2 plus 3, that is 6, and so on. Okay. And we will be using, we have two arrays here, and we'll be using to stack the arrays. We'll be stacking it horizontally and vertically. By that I mean I will be using a H stack method, and you would see array 2 got stacked horizontally with array 1. So this was till here 0 1 2 3 4 5 6. This was our first array, and this is our second array. This has got stacked horizontally, and then we have vstack function where it will stack vertically. Look at this. This was our first array, and this is our second array. So the second array got stacked vertically with array 1. Okay. Then we have something called as H split and V split. Like we do stacking, we can split the arrays into number of parts possible using H split and V split. H split is for horizontal split, V split is for vertical split. So in H split, what has happened here is we are trying to split array 1 in how many parts? We are trying to split it in 4 parts, because 4 parts, either we can split array 1 in 4 parts horizontally, or we can split it into 2 parts. So I'll take 2 here, and let's see how the splitting happens. Okay. The reason is it is a 3 by 4 matrix. So it has 4 columns, and we are splitting it vertically. So what has happened is essentially, if you look at this, this was the array, right? It has split over here in 2 parts. That is 0 1 4 5 8 9 one part, 2 3 6 7 and 10 11 as one part, right? And if you want to vertically split it, we have 3 rows. So there is only one way we can split. That is we can split only one way. That is what? We can split in 3 equal parts, that is 3 rows, because we have 3 rows. We cannot split it into 2. That's why I said whatever parts are, whatever equal parts we can split is possible. Only that we can do. We cannot do it in 0.5 or something. That split will not happen. Okay. And then how can we transpose a given array? So for that we have two methods. One is dot t, and another is One is .t that will be used with array. So here the array name is array underscore 2d dot t, and the another one is we have np.transpose function wherein you can pass the array, and in both the cases you will get the same result. Look at this. This is the result that you have got. So it is, both of them are um, of type nd array, and you are able to successfully transpose the given matrix. So that's all for today's video, and we will come up with more concepts as we explore Python for data science. So see you in the next video. Thank you.